click on record. Going to do that now. A second task a data engineer does is filter data. So we might have a large table with a lot of rows. For instance, sales, and then you have each customer of a website clicks on a product or buys a product, and then maybe you want to only have all data from after 2020. So that's a filtering operation. So you select part of the data based on some criteria. Another task is aggregating data. So you write a program, and then you can compute the total sales every day. And then another task is to integrate different data sources. So often you have many different types of data. For example, data from different systems, data from different customers, and you want to combine all that data into one data source. So that's integration or ingestion. It's also called sometimes. So what are the tools of a data engineer? It's programming, also scripting. So with scripting, I mean writing short programs, mostly reusing existing libraries, databases, algorithms and data structures, cloud, and parallel computing. And so we will talk about this in the following weeks. So what does a data scientist do? Well, one task is discover patterns from data. For instance, which group of users buy a certain item, how popular is another product. So that's one thing a data scientist does. Another thing is to learn predictive models. So these days, a lot of services depend on machine learning to make the life of the end users more have a more user-friendly user experience. So they do that. What you also learned in the data mining course. So which products will user X most likely purchase? Will the price of an item decrease or increase? Will users lose interest in their subscription? So to make that kind of predictions, you can learn a model with machine learning and try to predict that. And also, obviously, query and visualize interesting results for the business. So the tools of data scientists also include programming. Then there's more focus on machine learning, data mining, a background in statistics and maths. And he will also depend on databases and use visualization tools. So what is the data pipeline? So the data pipeline is central to many organizations, and typically you have different data sources. You can have a data sources, perhaps all the activity of users on your website. That can be one data source. Another data source can be more of a backend, where you have employees in the organization who enter information, like the inventory of products, things like that. And all these different data sources, we want them stored together in one data warehouse for analysis. So what we typically do, what data engineers typically do, is they extract data from each different source, then they transform the data, and maybe because every data source has its own file format and you want to transform it to another file format. And then finally, they load all that data back into the data warehouse. So the data engineer is responsible for implementing these components. And the goal is to enable data science. One goal is to enable data scientists, to do analysis on that warehouse and gain insights into the data. And obviously, the data pipeline can also contain machine learning models. So data processing is either real-time, online streaming processing, we call that. So that means, for example, if a user goes to Dreamland, the products they get on their page, they're in real time. There's some query in the background that goes to a large database, and they get their results immediately. More in the backend, we also have a lot of batch processing or offline processing. So for example, learning a new machine model, maybe that's done once each day, or large transfers of data from one system to the other. That's more done, that's commonly done offline. And also data engineers must ensure that the data processing is scalable. So with Scalable, we want to support a huge amount of users. Typically, one computer is not sufficient. If you have a popular website and you have thousands of users every hour, one server doesn't have enough of memory or maybe disk space to serve all those users. So typically we have different computers and a scalable system. Also, if the number of users doubles, we can add more servers dynamically. So that's the properties of a scalable system. Also reliable. Obviously the cardinal sin would be to lose data. So we need to have backups. We need to store the data on different servers. Also make sure that these modern online applications are available 24 hours, 7 days on 7, things like that. And also maintainable. So maintainable, that means we have continuously changes. There might be less users or more users. Also the systems need updates, software updates, hardware updates. So it should be maintainable. So another overview of the skills of a data engineers, and you see this Venn diagram here, and actually you see that the data engineer is kind of an intersection between a software engineer and a data scientist. So he combines skills both of a software engineer and a data scientist, and also there's some additional skills specifically for a data engineer, such as data warehousing, or distributed programming with Hadoop. So he needs knowledge of programming with Python. He or she has to have knowledge of algorithms and data structures, needs basic knowledge of operating systems and networks, knowledge of distributed systems. So these are systems that compute or store data not on a single computer, but on multiple computers. Experience with big data technologies, such as MapReduce, experience with cloud platforms, knowledge of SQL, NoSQL, and even more software engineering skills, system administrator skills, machine learning skills. So that's a lot of different topics, but don't worry. In the following weeks, each of these will be discussed in some detail. So here's another overview of all the different tools, technologies, and platforms. So these are a lot of different things, and we will go into them the following weeks. So in the middle, you see a lot of brands of databases, MySQL, Oracle, PostgreSQL. These are relational databases. So a database, I have an example in the next slides, stores a huge amount of structured data. And there are two flavors, SQL and NoSQL, and they have different properties, and they will be the main topic of week 5 and 6. Then on the left, you see Hadoop MapReduce, Apache Storm, Apache Spark, Apache Drill. So these are tools for big data processing. So at some point, your data doesn't fit into memory on a single machine, or you don't have enough disk space to store your data on a single machine. And then you have to go to these big data processing tools that enables you to write programs that are executed on a lot of different computers. And as a programmer, you don't have to worry about how many computers there are. You just write your program and run it on MapReduce, and MapReduce will ensure that parts of your processing are done on every machine. Then you have file storage, distributed file storage with Amazon S3 is one popular product. Hadoop is another. You have your cloud vendors, AWS, Google Cloud, Microsoft Azure. These provide the hardware in essence. So you used to, if you wanted to, in the past, if you wanted to serve some, have a website or something like that, you would have to buy your computer and network equipment and install it in the office. But these days, it's more common to use online platforms. And obviously, you also use Google, and maybe for your Gmail. Well, Google also provides a lot of services for creating your own servers in the clouds. Then we have data design of data pipelines with Airflow and Luigi. We won't discuss this in this course, but you can think of it of tools to click your data pipeline together. And finally, we have some visualization tools for visualizing data and different software tools that are available. Okay, so here is an example, and you see on the left the LinkedIn page of Bill Gates. So it has his name, then a summary of his current occupations, his experience in the past, his education in the past, and his contact information. So this is how the website looks. And in the backend, LinkedIn, of course, has millions of users. So what they typically would do is have a database, and they would store each record, if you want, each piece of data in a separate table. So you might have the user table with a unique identifier. So Bill Gates is user 251 with his first name, last name, a summary of his current occupation. So that would be the one table, and then you have links between tables. So for example, Bill Gates has two past positions. So positions corresponds to experience in the LinkedIn example. And you could store that in that way. So it's a different table and it's linked with an ID. So that's an example of a database. You can also store the same information in a file. And here we see a JSON document. So it's another format, and it's the topic of the next presentation, where we store all this information in a dictionary. So it looks like a dictionary in Python, and it's also a way to encode that information in a text document. This is an example of a cloud system. So here we show Amazon Cloud, and we will do exercises with this system in the third week. And what it enables you is to add different computers. So here on the left, you see instances, and you see that I created here a row. So actually that row represents a computer. So I started a computer, and it's available over the internet. I can connect with it. I can install software on it. And it's very easy these days. So just with a couple of clicks, I can create 5 computers and have them running day and night online. Amazon will make sure that they have enough power, that there are backups and everything. So it's a very important piece of technology which enables the creation of new applications online very quickly. This is a more complex example, a lot of things to explain here, but this is actually what happens when you go to Dreamland. So you're an end user, you go to the website dreamland.be, and finally you get a website with all the products, maybe some promotions on it, and then you can click, and each time you click, you do another request. So what happens behind the screen is you have these different systems. And you can think of every system, so the green, red, and yellow blocks, as a different computer. So the first thing that happens is you connect, and actually in the backend you connect with a load balancer. So Dreamland maybe has thousands of users every hour, and if they all go to one web server, so one server that gives back the web page, that server would crash. It would go out of memory. So to make the system scalable, you put a load balancer in front of it, and the load balancer balances the load. So here we have 2 web servers, and we assume that 2 web servers are enough to handle all the user requests. Oh, wait me, one more instance. Yeah, sorry. So that's the first step. And finally, these web servers give back web pages, sends back data with the web page content to each user, and 50% of the users is handled by web server 1, and 50% is handled by web server 2. So what we also want to do is store the interactions. So the users, if they, at least if they accept their cookies, we track their behavior. So we track on which products they click. So we would store that in log storage. So that's the arrow going to the top. We would store that in log storage, and from that log storage, we would maybe create a JSON document. So that's the example I showed before, and save it and export to the data warehouse. So another thing the web server does is get all the data it needs to create the web page. So one thing it needs is to get all the images, all the pictures of the different products. So it might get those from S3 storage. So the web server will make a request to another server, which is it's hosted by Amazon S3 in this example. And also the web page might show the most popular products. So it needs the name and the price of the most popular products. And that kind of information will typically come from a relational database. So you will do a query, and it's in SQL. It will do a query to the relational database, and the relational database will respond with a list of popular products, their name and their price. And then finally, also on the Dreamland page, we will have some recommendations which are personalized. And these are extracted from a recommender system. And so you might do a REST call. We will see what that means later on. And it will return maybe the top 20 most, the 20 most relevant documents for that specific user. So these are returned by the recommender system online. But obviously it's not obvious, but the way these recommendations are computed, it's based on machine learning. So we will have to do some learning based on past data, how to make good predictions for a new user. So that's this yellow block model training in the back, and that might be done on MapReduce, because these are heavy computations, and they're not performed by one computer, but maybe 10 computers in parallel on top of MapReduce. And the data scientist you see here in the right bottom, he's responsible for creating a model, but all those other steps, they're all things the data engineer is involved with. So he will set up the different systems like the data warehouse, the relational database. He will write programs to transform data between these different systems. So the data engineer actually has a lot of work. So more about this course. What is the goal of this course is to give an introduction of the most important techniques and technologies for handling data. We will focus on some practical skills and concepts for storing, processing large amounts of data, understand their complexities, and that you know when to use what tool and what type of technology. So we will also cover some basic knowledge on topics from computer science. And finally, I don't expect you to become data engineers, but you should be able to to communicate with developers, software engineers, the data scientists, and know the jargon. So that's really important. One instance, I'm gonna drop my curtains because the sun is in my face. So an overview. Sorry. So an overview. So the first 4 weeks of this course, we're going to focus on fundamentals. So data formats, that's the presentation after this one. Then some fundamentals about a single computer, about networking and the cloud, data structures and algorithms, and data processing with Python. So that's the first 4 weeks. It's a little bit fundamentals. Then week 5 to 7, we're going to talk about databases. So that means data storage, storing, querying, so retrieving information and visualizing large amounts of data. Then week 8 and 9, we're going to talk about distributed computing, so computing on top of different machines. So that's MapReduce and also recommender systems as a kind of use case. So I'm going to talk about my work at Frumel because, yeah, for me it's easy to have extract some real world examples and use cases based on my work in Frumel, and it's highly relevant for this course. And then finally, in the last 3 weeks, you're gonna work on a group project. So that means you're gonna write your own data pipeline with Python and also with SQL. So that's the last 3 weeks, starting from the end of April. So part 1, fundamentals. That's the first 4 weeks. We're going to talk about how can we represent data conceptually and also how to store it, so different file formats. A little bit about general information about what a computer is, how an operating system works, and what networks are. Talk about cloud computing, and also algorithms and data structures to efficiently process, search, and store data. So that's the theoretical part. There's also a practical part, which you will practice in the lab sessions. So we're gonna do a lot of data processing with Python. So at the end of the course, you should be able to do that. Find patterns in texts with regular expressions, work with Linux in the command line, and also with Amazon Web Services. So that's one of the cloud system providers. In the second part, we're going to talk about data storage, so relational databases using structured query language, document storage using NoSQL systems. Also talk about replication of data, partition or splitting of data, visualizing data, and web application programming interfaces. So that's the theory. Skills, we're going to do SQL. You're going to learn SQL. So that's a high-level programming language, and it enables you to extract information from databases, do some analytics with Python, and visualization with Python. The third part is shorter. It's only 2 weeks, but we're going to talk about distributed computing, so MapReduce for parallel processing of huge volumes of data, and then use cases mostly inspired by my work at Frumel for recommender systems. So here we're going to practice also with Python, but this time using Spark. And then the final part, that's a part when there will be no lectures, so there will be live Q&A sessions on Blackboard to help you, but you should work individually. So we have a project, every group, so you're working with 3 students in one group, must implement a data pipeline in Python, and we expect a report where you report your findings, a small report, and also include your source code in Python and SQL. So what does the data pipeline will look like? Well, you will have to work with AWS clouds, so that's the Amazon cloud system, query data, for example, from a data warehouse, clean, filter, and aggregate that data, visualize that data, compute statistics and features, and perhaps, that's not entirely sure yet, learn a model to predict something. Here's another overview of the class weeks and topics. That information is also provided in Blackboard. So you have a nice schedule. So the first 7 weeks, following weeks, we will have a lecture and a lab session. Then there's no class. Then there's the Easter holiday. Then the final 2 lectures. And finally, from the 29th, the lab session and will be skipped, and we will just do the projects. And so also the last couple of weeks, it's only the projects. Important reference material. So here, I would recommend, you have to see about it, but these slides are mostly based on designing data-intensive application. So it's a book by Maarten Klepman. I use the 4th edition of 2018. It's also the latest edition. So a lot of the material is based on that book. You can buy it at, for instance, bol.com, and it's 24 euros for the electronic version or 45 euros for the paper version. So I do not expect that all of you buy the book, but if you're really interested into the topic and you feel that the slides are too general, or you have more questions about, you want more details about the different topics, then I suggest you buy this book. So, sorry, and then there's also for the foundation, so that's the first 4 weeks. We'll talk about operating systems, computer networking, algorithms and data structures, and Linux. So obviously there are a lot of more specialized books on each topic. So these are just general references, but these books go to in way more detail than I'm going in this course. So I do not expect you to read them or something, but just to provide that information. Okay, so the class formats. Every week we will have a theory session online, obviously, due to the COVID crisis, pandemic. In the afternoon, there's a lab session from 2 to 4. And the lab sessions will focus on the skills discussed during the lectures. So you can work alone or in groups of 2. So you can meet online. It's more, I think it's more, hey, we're all alone at home. So it's maybe nice that you work with 2 and share your screen or something. So for the lab sessions, they're not mandatory. You don't have to hand anything, but it's a good opportunity to understand the theory, and it's especially important for the projects. So these are the teaching assistants, some of which you may have seen before. So today, Stina will do the lab session, and then the other assistants you will see every week. There will be a different assistant for the lab session. Okay, so we use Python as our main language. You know it from data mining course. It's an easy language to quickly create something. A big community, especially for data science and data engineering, and it's also used in the industry. So that's ideal. So how do we are going to organize this online course? First, we have the lecture, so that's a mix of either recorded sessions or streaming sessions every week. So I'll make sure I record every session, so you can also always look at it at a later time point. All information will be available on Blackboard, so presentations, but also I'm also planning to do a lot of hands-on demonstrations. So the lab sessions, it's the same principle, also all information on Blackboard, and I suggest you work in pairs of 2. So if you have questions and answers, you can use the forum on Blackboard, also after presentations or during the lab sessions, you can ask questions. So one more thing, computer says no. So for the lab sessions, you are expected to do some programming in Python. And one very important topic is getting help. And so when you're programming and you're getting, it's normal that you get stuck. And because, yeah, we're all online, it's important that you find answers to your questions yourself. So that's why I included these slides. So today, many different tools and technology exist, and even for experienced data engineers, it's important that you know how to Google. So look up documentation and solve programming errors. For instance, you have to open a file in CSV format. Okay, the next presentation I will explain what a CSV format is, but suppose that's the task. So what can you do? You Google. You Google open CSV file, but then you get maybe only information about Excel. Excel also supports CSV files. So obviously you don't want Excel, you want to program that in Python. So you rephrase your query. So you query again, and then you type open CSV file in Python. And then you get another list of results from Google. And maybe the second link has some official technical information. So that's a good place to start and learning about how you can open CSV files in Python. But maybe the technical documentation is complete but requires a long read, and maybe you want something simpler. So then you query open CSV file in Python, tutorial example. So, and if you do that, you find a YouTube video with step-by-step instructions, and that's maybe more useful for you. So that's how you can look up information. And it's especially useful when you have errors. For example, in preparation of this course, I actually got the following error. I wanted to read a CSV file with pandas. I'll introduce that later. And I got this error. So I open it in Python, and the Python system gives me a Unicode decode error. And here you have the message, UTF-8 codec can't decode byte 0x91 in position 23. So even for me, that's something a computer returns, but allez, you're stuck. And you just copied the example from the slide, it doesn't work, what do? So I would copy that message and just enter it in Google. And then often you get a lot of results because other users had the same programming error. And one very important website is stackoverflow.com. So in stackoverflow.com, you have millions of pages, and every page is about an error you can have in programming. And then at the top of the page, you have some person who experienced that problem. And then below in the page on Stack Overflow, you have a number of possible solutions suggested by other users. And so, and in my query, if I go to the first page, I get some information, but it's too complicated. So that's not a lot of help. So I rephrase my query, CSV file can't decode bytes, whatever, and I add pandas, because I was working with pandas here. That's a Python library for data analysis. And then you get this information. So you get some other user who had the same problem, but with pandas. And then you have here a solution. So Then I know how I can extend my code. So apparently the problem was with encoding. Yeah? So I tried that in Python and suddenly it works. So that's really useful that you know that you can solve your own problems. Googling, rephrasing queries, finding the solution on Stack Overflow, and then trying that solution in your own code. And so in general programming in Python or in any other language, it's a trial and error process both for beginners and more experienced persons. So mastering Google and Stack Overflow is one of the most important skills. Also, syntax is very important. So every bracket, every comma has to be in the exact place. And also, if you're programming, you have to prepare that it takes several hours, and it's really a trial and error process where you continuously do Google searches. So you have to prepare for that, and that's normal. The computer is a complex machine. It doesn't have common sense. It's basically an advanced calculator. And also, as humans, we're typically bad at programming right from the start, or creating a couple of lines of code, and then it will never be correct from the first time. So that's normal. So key ideas: keep it as simple as possible, and don't try to invent some. It's much more easy to write difficult code than to think about the problem and keep it as simple as possible. Also important is Murphy's Law. Anything that can go wrong will go wrong. So if you have 5 statements in Python, you can expect that 4 out of 5 will be wrong the first time. Program step by step, check with print statements, and also do not assume the computer has it wrong. The problem is in the chair, not in the computer. So that's picnic. So tools. There are 2 tools which we will use during a lab sessions, and also the interactive lectures. The first tool is Google Colab. So we will use that for most of the exercises, and most of the exercises are in Python. And here you find a link. So that's something you can try after this presentation. It requires a sign. It's free. It just requires a Google account. So if you don't have a Google account, you should create one. It's similar to Jupyter. I don't know if you have used Jupyter before, but it's an interactive notebook, and you can write one Python statement at a time and then get the results after evaluation. So we will use that with exercises with pandas, for file formats, pre-processing data, visualizing data, analyzing data. And Google Colab uses notebook files. So these are IPython-B. That's extension IPNB. And you can download those files from Blackboard, and then you can upload them with Google Colab. So Stine in the lab session will give a small tutorial on Google Colab. The other tool we're going to use is Amazon AWS. So I will normally in the following days you will receive an email with your account on awseducate.com. So it's free because normally you need a Visa card, but I will create a classroom and you will all be invited. And you get, I think, 50 euros of credits. And with that 50 euros of credits, it's more than enough to create databases and servers. And you will do practice on that in the lab session starting from week 3. So an overview of the lab sessions. So I'm not going to read this entire table, but a lot of exercises will be in Python. An exception is in week 3 when we will do exercises on the cloud with AWS, and in week 5 when we're going to do exercises for querying databases with SQL. Also for the project, you will use Google Collaborate, and Google Colab and AWS. Okay, so the project lab sessions are the best practice for the projects. We will create 5 different projects, and a group will consist of 3 students. I propose we have mixed groups, so the masters in business economics or bedrijfskunde should work together with the handelsingenieurs. So I expect, because there are more handelsingenieurs, I expect 2 handelsingenieurs in each group and 1 business economics or bedrijfskunde student. Also important, it's a group project, but I want every student in the group to be involved in each phase. So working with the cloud, programming in Python, SQL, and writing the reports. And so not one student who does all the programming and one student who does all the report writing. For the project, you can meet online and share code using Google Colab. And practical is that the project is on 5 points out of 20. And it starts on the end of April, and the deadline is the end of May. So the exam, it's an oral exam with a written preparation, and you can expect general questions on the theory and also to do exercises on paper. So in the slides and also before the exam, I will give a lot of example questions. So you have an idea about the complexity of the questions. But for instance, which file formats are used for storing and communication of data? Provide 2 short examples in JSON and XML for storing student grades. So that's an instance of a questions you should be able to solve after seeing the next presentation. Also, accept to do exercises on paper, so programming exercises instead of a computer. So I don't expect that you are becoming software engineers, but you should know and apply general programming techniques specifically for data engineering. So type of questions you might expect is complete the following sample codes, or provide a short XML example in JSON or XML, things like that. So that's for the exam. So it's a closed book exam, and since 5 points of 20 are on the projects, then 15 points remain for the exam. So this concludes the first presentation. Are there any questions? You can, I guess, raise your hand or chat or something. Are there any questions? Anyone? Do we have to prepare anything for the tutorial? No. So the tutorial I'll be giving after this presentation, you can just follow, and in the afternoon in the lab session, you will have to work with Google Colab. So it's interesting that you already create a Google account if you don't have one, and go to the website, this one. Yeah, can we choose the groups ourselves? So yes, you can choose the groups yourself. The only requirement I have is that it's a mixed group. So no, maybe it's unavoidable, but I would avoid having 3 handle engineers in one group. Will we learn enough for the AWS certificate? If not, where would you recommend us to learn more? Okay, for the AWS certificate, that's more, you won't learn enough because we only have 1 week on cloud computing. So I think for the AWS certificates alone, you should have at least 5 or 6 weeks. So we will only cover the basics of AWS, and that you have a feeling of how cloud computing works, but not enough for the certificates. Did the students from last year? No, they didn't use the same textbook. So that's the textbook from Martin Klepman is a new one this year. Okay. Any more questions? Okay, so I propose I stop the recording now of the session, and then I'll continue with the second presentation. But first, I suggest we take a 5 minute break. Fine? So see you again in 5 minutes.